got from chapter 2, okay? I will hit those. So let's go on with this now. So one of the things, the main thing is, what if we've differentiated a polynomial where each term is a power function. It might have a coefficient or something, but a lot of life stuff is not that way. The sine of x is not the typical function. You know, it's sine of some function. Sine of, there's a function inside a function type stuff. And differentiating that is a little different, and that's where we introduce what's called the chain rule. Also, we'll give the definition of y equals a to the x in this set right here. I'm going to move on from there. We'll talk about that other stuff, but for right now, I'm just going to go with here. Okay, here's the idea of the chain rule. This, you know, the composition of function is what this notation is saying. There's a function inside of another one, like this, okay? So the notation is f of g of x. And I've got that on another sheet, but I'll go to that and talk about that again later. So the function is actually f parentheses g of x close parentheses. So it's like this without the bar, you know? G is inside of f. Well, the derivative of that composition of function is, now check this out if you haven't seen this before, it's not super complicated, but it's just new. And you've got to take the derivative of the outside function, leave the inside function just like it is, take the derivative of the outside, make the change on the outside, and then take the derivative of the inside. And it's a product. You multiply by that. Okay? Another notation that they use is if you're taking a function that's made up of u of x is inside of it, okay? And u of it inside, it's the function composed of x, but there's a function inside the function. Here's another way of denoting it. You take the function of the outside function and then multiply that times the derivative of the inside function, okay? So let's look at an example of that. Okay, here's a biggie. All right, so there's a polynomial, a trinomial. It's got 3 terms. It's a quadratic, and it's got the power of 99 on it. All right, and so you're asked to take the derivative of this. So what do? You take a derivative of the outside function. The outside is there's this function, this quadratic's inside this other one, which is something to the 99th power. It's something to the 99th power. That's the outside function. So you take the derivative of that. You take the derivative of that. You bring the 99 down front and subtract 1. That's what we do with taking derivatives, power rule. So you bring the 99 down front, subtract 1 on the exponent, leave the function inside just like it is. And then you take the derivative of this function, all right? So that you take the derivative of what's inside, and you can see that that's at 2x minus 3. Boom, right here. So the only thing to do at the end would be to combine these two, because this has got a huge power. You can't touch this if it's got an exponent on it. You can't blend anything inside there. This is intact, okay? But these two are to the first power. So you could combine these two or bring this out front or something like that and get the solution in that way. Notice that if we were asked, what causes this function to be equal to 0? Okay? Having it in this format lets you know, set this equal to 0, and I can tell it's equal to 0. Because the derivative, remember, is the slope. The derivative is the slope. But this right here is the chain rule. Let me go through it one more time. You want to take the derivative of this function, you bring the exponent down, subtract 1 here, leave this in here, and then take the derivative of this and multiply it. So you bring the 99 down, boom, subtract 1, leave this like it is, and take the derivative of this, and that goes here. That's the chain rule. Okay, So notice here, we've got another one, the sine of some function. And it's not just theta or x right now. And remember, you guys, don't get caught up in, here's another letter, but that pi is a number, okay? So it's a constant. This is a constant. And when you take the derivative of this, we've got to do that with the chain rule. You got to do this. So we got to take the derivative of what's inside. That's going to go away. And don't get distracted by the fact that this is an x. If you want to, replace it with an x. That's 4x minus pi over 2. But now we take the derivative of this. So we take the derivative of the outside. The outside is sine. What's the derivative of sine? Cos. The derivative of sine is cos. That's the outside. The inside stays just like it is. Then you multiply by the derivative of this, which is, this goes away because it's a constant, and the derivative of 4x is 4. So we have 4 times this, which means simplify it, bring the 4 out front, and you get this for your answer. Any specific questions about that at that point? I've got a bunch of problems I want to practice and go through. Let's do one more situation here, okay? Here is e to the function, all right? Remember what the derivative of e to the x is. It's e to the x. So this rule, and this is, I like this notation, but this gets kind of clumsy. But if you have y equals e to the u, and you know u is, it's a function in terms of x, u is a function in terms of x, e to the u, then y prime, the way I like to denote it, is e to the u du. The e to the u, you got to multiply times the derivative of this. And the way I write that is, it's commonly recognized, and it'll help downstream a little bit. The derivative of y is going to be equal to, you get this back again, just like it is, just like e to the x, but then you got to take the derivative of this. Again, and when it's e to the x, the derivative is 1, so you do use it then too. But in this case, we've got u equals this. So you've got it, so you get, when you take the derivative of this, you get this back just like it is, rewrite it exactly like it is, and then multiply times the derivative of this, which is 3. Bring the 3 out front, there's the answer. Okay? Questions on that? Again, we're going to practice a few in just a minute. Look at this one. So cosine y equals cos of 2e to the x. Outside function is cos. Inside function is 2e to the x. So take the derivative of the outside. Derivative of cos is negative sine. You got to keep track of that. You leave this just like it is. 2e to the x stays there. Okay? So the derivative of the outside is minus sine for the cos, and that stays just like it is for this. And then you take the derivative of this. And the derivative of 2e to the x is 2e to the x. So you got the minus sign out front, you bring that out front, and you end up with 2e to the x sine 2e to the x. Okay? So here's some rules. I'm not going to ask you guys to deal with secant, cosecant, and cotangent down here. Those are there. You can find that sometime if you want to look it up. But the ones I do want you to know are, and see, they make it a little more complicated here. This is u in terms of x, and it's important to know that. This is kind of saying this thing's in terms of x. I typically say, and I'll show you my note, I got a formula sheet I want to show you in a second. But e to the u, the derivative of e to the u is equal to e to the u du. Okay? The derivative of sine of u is equal to the cosine of u du. Derivative of cos is equal to minus sine u du. You got to take the derivative of whatever this other function is. And tan, I kind of worked with learning it as 1 over cosine squared. So if I do that a lot, that's what I'll do. This book talks about secant squared. Remember, secant is 1 over cosine. Cosecant is 1 over sine. And cotangent is 1 over tan. But we're not going to dwell on those. If I do anything other than sine and cosine, it's going to be tangent. So you may want to recognize that, just familiarize yourself that, and I'll show you the other formula sheet in a second. Okay? Let me see here. Let me look at the next screen and see where that takes us. Oh, okay. So now if I ask you to write the equation of a tangent line, I'm going to ask you that on the quiz on Monday. Okay? I will. So that means now you got to find the slope, which means you got to take the derivative of this function and plug in x to see what, and that whatever the slope is going to be the derivative of this at x equals y, x equals 0. Okay? So in this function right here, notice what we got to take the derivative of this. Notice this isn't just e to the x. So when we take the derivative of this, so look, they got good notation here. F prime, the derivative of f, they don't call it f, but yeah, y equals f of x right there. The derivative of this is equal to the derivative of that. Bring the 4 out front, great, times the derivative of this. And the derivative of this is you got to use the chain rule now because there's not just an x. So you take the derivative of e to the x, you get, e to the 5x, and you get e to the 5x back, times the derivative of this, which is the derivative of that, and the derivative of 5x is 5. So the 5 and the 4 are on the same level, so you end up with 20 e to the 5x. This is the slope of this function at any point, all right? Well, we want to write the equation of the line at x equals 0, so we plug in 0 here to find the slope, 0 to this function to find the slope. And that gives us e to the 0, which is 1. That gives us 20. So the slope is 20, and then we use the 0.04 down here. They use point slope form here. Here's x1, y1, and here's the slope. And you simplify for y, and you end up with y equals 20x plus 4. And they notice they do show the line touching the graph at x equals 0. Make sure you always check that, you guys. Do it yourself and make sure you got that. Okay? So with that, I'm going to pass on that. That's more of a complicated problem. I tell you what, I'm not even going to do a to the x. Let's problems on the practice sheet that I've given you. This is on the practice sheet. And look at the second, I put 2 pages here. Practice sheet, these are not to be turned in. This is just for you to practice. And I can give you the answers for those a little later, maybe over the weekend, I'll give you those. But the idea is I want to work through these. I want to work through those in just a minute. But here's the formulas and the notation that I've typically used, okay? So if you've got derivative of e to the x, you get e to the x. Well, if you've got e to the u, and that's a function in terms of x, then the answer is e to the u du. That's what I'm referring to, and that's saying you got to take the derivative of this, okay? We're going to deal with this new rule coming up here, the natural log. We'll talk about that in a minute. But here's sine. Derivative of sine is cos. Well, derivative of sine of some function, u, you get cos, but you got to do cos of u times the derivative of whatever's in here, okay? Same thing the other way around. You get minus sine, but you got to take the derivative of this function. And tan, you got to remember to take the derivative of the function that's in there, okay? We got the product rule, quotient rule, a couple different ways of noting it. And yeah, this is a short form for me. I'm not really stickler about making sure you use the x, but this is in terms of x. So I just use abbreviated notation here. And I do write the product rule. Notice it's the same order as the quotient rule. F prime g comes first because that's what it is in the quotient rule, and it's got to be that because of the subtraction. But in the addition, it could be either way. Doesn't matter. Doesn't. But I'm writing it like this, so if you're memorizing it, getting it down, I think that it'll let you remember both of them, so to speak. I don't know, it helped me. And here's the chain rule now, okay? And we'll talk about this stuff on a little bit later on. All right, so I want to back up here and do a couple of the practice problems. Let's do this. I want to show you 1 through 4. Let's do 1 through 4 right now. So if you got a piece of paper out, you can look at this with me. I want to put this on my iPad and work through this, okay? Okay, so, and one rule, you guys, one rule I'm going to be using a lot, and it's going to be something I stand with, is that if it starts with the radical, the simplified answer will be end with the radical. If I give you the problem and it starts with the radical, well, we've got to take it out of radical form to get the answer. You know, you make it a fraction and then you can do the algebra. Well, I want you to end up, if it starts with the radical, you end with the radical. If I start with the square root of x, then I want you to end with a radical. Well, something I want to point out here is that it also works for fractions. We've done a polynomial and the exponents all been integers all the way through here, all right? So taking the derivative of an exponent with a fraction, let's do this. So we end up with this. The derivative of this is equal to the derivative with respect to x of x to the 1/2, all right? So we got to put it in that form in order to take the derivative. Now, follow the rule, the power rule. The power rule says bring the exponent down front and subtract 1 from the exponent. That's what you do here also, okay? So the answer to this now, it's no longer d dx, I'm taking the derivative. You bring the power down front and you subtract 1 from the exponent. Now, what I typically do, in the book, they do -1, but I just save a step. I rewrite it with a 1 as a denominator, having the same denominator as the fraction. So it's going to be 1/2. I got to subtract 1, so that's going to be -1, which is -2/2. Okay? And that turns out to be equal to 1/2 x to the negative 1/2. All right? So traditionally, leaving negative exponents in won't be appropriate. A negative exponent is not simplified. But I said if it starts with a radical, end with a radical. So I want you to go further than just give it a positive exponent. I want you to change it to a radical. So to get rid of the negative, let's do that first. This is equal to, we got the 1/2 out front, 1 and 2's there. Notice the x to the negative 1/2 on top becomes positive 1/2 in the denominator. So you end up with x to the positive 1/2 down here. And then since I said change it to a radical, then the correct answer is going to be 1/2 square root of x. Okay? So given this problem, the way I'm asking you to simplify it is, go through the process. You got to change it to a fraction, do the rule, subtract it, get the negative exponent, move the negative downstairs, change it back to a radical. The final answer is that. Any questions at all about that? If you've got one, make sure you unmute yourself, okay? That's very, very basic, okay? Now look, here's another one. Let's do the second one. What I wanted to do here, I moved this one over. They give this example in Sapling, and I wanted to show you, I want you to, what would that fraction, if that wasn't written as a fraction, as it was written as a radical, what would it be? Stop and think to yourself right now. How would that be written as a radical before it became a fraction? Okay, stop and think now. The denominator is the root. The numerator is the exponent. Therefore, this original problem might have been like this. It's x square root of x to the 3rd power. And that 3 could either go underneath the radical, or it could go out top, up on outside the radical and cube the whole thing. This is another way of writing this. Okay? So that's practice. You got to, guys, you need to get that down too. I'm going to ask you to go back and forth. You need to have square root, even though there's not a 2 there, there's a 2 in the denominator. This one, again, has got a 2 and a 3, and the 2 is in the denominator. So now let's take the derivative. So we're going to follow the rule. So the derivative is, bring the exponent down front, subtract 1 from the exponent. That gives us 3/2 x to the 1/2. All right, and well, that's That's positive. That means it stays up. So, and it's going to be upstairs. It's not negative. So the 2 is the only thing in the denominator. So I could rewrite this as 3 on top, square root of x on top, and 2 on the bottom. Okay? So notice what we started with. We started with, we end up with 1/2. We had 3 halves, and you just have 1/2 in the end, so that's just the square root. And it's not cubed, it's reduced to a single power. So, any questions on that at all? Okay, now let's do the chain rule. Okay, tell you what, I'm going to do this problem. These are S's. That's not good. Tell you what, let's go instead to, I'm going to go to the practice sheet that we had. Any questions on this before I go? We can come back to this problem a little bit. It's got a negative and a chain rule, so I want to do something simpler first, all right? So what I'm going to do is I'm going to go back to the problem sheet, the practice sheet, and all right, and let's look at the top 4 problems here. I did the first one. We did something similar to the second one. Make sure you do that. I'll do that one in a minute. Now, look at number 3 and number 4, okay? Number 3 and number 4. Notice what we've got here. X in the denominator. That's x to a negative exponent. So let me write these down. Number 3 is y equals 1 over x. And number 4 is y equals 1 over x to the 3rd. I'm going to do those. I'm going to go over to my iPad again. Let's go back to my iPad. And get the logic down of the sequence of approaching the problem, all right? So right now, the x in the denominator isn't the way to get it. Once you get things down, you can make adjustments and do it the way you want to. But right now, the idea is you need to bring that upstairs to take the derivative of it. And notice if you bring it up, it's going to have a negative exponent. Well, remember, you use the power rule for this also. If it's a fraction, you use it. And if it's negative, you use it. You still follow the same rule, okay? So this is equal to, I'm going to rewrite this as x to the negative 1, okay? So now y prime, notice I could have also written d over dx of x to the negative 1. I'm going to write y prime, that's taking the derivative of this function. So what I do is bring the exponent down front and subtract 1 from the exponent. At first, you may want to meticulously write it all down, write down the steps. You bring the exponent, the negative 1 down front, and now you subtract 1 from the exponent. Subtract it, okay? So you end up with minus x to the negative 2, okay? And I said no negative exponents, that'll be shared, so we got to get rid of it by taking it back downstairs. So we've got negative, and that's going to be 1 over, and the x squared goes to the denominator. All right? So we get negative 1 over x squared. Notice what happened. When you typically do a function, or if you have y equals x squared, positive, the exponent, positive exponent, reduces by 1. Well, notice this. This is in the denominator. This is x to the 1 down here. Notice what happens. The answer is we get a negative answer, and it increases by 1 in the denominator. So it's x squared. All right? In the denominator is the final answer. All right? So let's look at number 4 now. Let's do the same thing. It's the same concept. This is equal to x to the negative 3. So what do? We get y prime is equal to, bring the negative 3 down front, subtract 1, we get negative 3x to the negative 4. So if I want that answer with the positive exponent, that's going to be negative 3 on top and x to the 4th on the bottom. Okay? Again, notice what happened. The exponent increased by 1 in the denominator. And this time we got the coefficient because we had to take the exponent down front in order to get it. All right? Questions on that at all? Okay, now what I had said before was the chain rule. Let's back up and let's go to the I think that's it right there. Okay, so look down here now. Okay, natural log, I'm gonna hold off on that. This is a new rule you gotta get, okay? This is section 3.4. They bring this up there. And I'll talk about that in just a minute, right? It's a new rule. This is very straightforward. And then using the chain rule, it's also kind of straightforward. You'll see, we'll talk about that in a minute. But right now, let's practice chain rule on these problems down here, all right? And then we'll go back up to natural log and go from there. So let's do number 7. Number 7 is y equals, I got x to the 3rd plus 100 to the 10th power. And on number 8, I've got y equals 1 over x to the 4th minus 2x to the 3rd. All right? And then I'll put down 9 and 10 also. 9 and 10 will be, 9 is really straightforward because we know the answer to that. Is e to the x, right? Y, it's coming. Okay, so here's what I wrote. This you guys know, okay? And remember, this is the rule right here. And that's what we're dealing with here. We've got u, some other function, something more than just ex. So what we got to do is, for this function, this is u, so I got to take the derivative of that and multiply it by the derivative of this times this back again. So if I take the derivative, I get this again exactly like it is, times the derivative of the exponent. So that means my answer ends up being 3e to the 3x minus 4. Okay? It's that simple. When you've got e to some power, if it's e to the x, then the answer is e to the x for the derivative. But when you're doing an e to the u, where u is some other function, then you got to take the derivative of that function and multiply it by it, and that's the answer. Okay? So let's go back now to number 7. And so this is, now we're going to use the chain rule. So we've got that. Is there any adaptation or anything we can fix to make it simpler? No. So what we're going to do is we're going to take the derivative now. It's ready to take the derivative. So we got to bring the power, do it yourself. Stop and think what you got to do. Bring the power down front, subtract 1 from the power, and then multiply by the derivative of what's inside the function. So I get 10 x cubed plus 100 to the 9 times the derivative of x cubed plus 100 is just 3x squared. And now the 3 and the 10 are on the same level here. So this is actually equal to 30x squared times x cubed plus 100 to the 9. All right? And you guys got to remember that this, because that 9 is on here, and any bit number other than 1, you can't touch this inside here. That x doesn't go in, and the 30 does not go inside that parentheses. That 9 locks it all together, okay? Any questions on that one? Okay, look at number 8. This one, notice it's in the denominator. So there's some simplifying I can do before I take the derivative. You could use the quotient rule on this, you guys. You would get the same answer, but it's easier to just make it a negative exponent and go with that. So what I'm going to do is rewrite this as, this is x to the 4th minus 2x to the negative 3. All right? So notice what we have. You've got a function to a power. That's chain rule. And notice the power is negative. So I'm not going to leave negative answer when I'm done. I can expect that this is probably going to go up to a 4 down in the denominator. Grow is in the denominator, remember? But I've also got to remember to use the chain rule. So let's take the derivative now. Y prime. Bring whatever the exponent is, bring it down front. Negative 3. This stays exactly the same. Subtract 1 from the 3. Don't get caught on that, you guys. Sometimes you automatically subtract 1, it makes the 3 smaller. No, when it's negative, it grows, okay? So make sure you keep track of that, and then multiply times the derivative of x to the fourth minus 2x. So that's going to give us 4x to the third minus 2. All right. Now notice we've got the -3, and this is down to the first power. I'll bring it out front. You could multiply it out and distribute it, but if you're looking for a factor, you might even take the 2 out of this and simplify it. But there's a couple different ways you could write this. What I'm going to do is go ahead, and they're on the same level. I'm going to go ahead and multiply it out? I'll multiply it out. They're just to remind you that these are both to the first power. So that means they're on the same level. So that's what, going to be -12 x to the third plus 6. That's probably not ideal. But the idea is that now we've got x to the fourth minus 2x to the -4. All right? So what does that do? This goes to the denominator, the -4, the exponent. So that means we end up with -12 x to the third plus 6 on top, and x to the fourth minus 2x to the fourth on the bottom, +4. So we end up with the derivative is actually this. So we started with this to the third power in the denominator. We ended up with the same thing to the fourth power in the denominator, and this other thing, which turned out to be the derivative and the product. You know, you had to bring the exponent down front and using the power rule. Questions? And that's what I want, okay? So that is going to be from current slide. All right, so I am not going to ask of you on the quiz Monday, or I'm not going to be asking you much. There's a rule about what you do with log, log, log base 10. The main thing I'm going to focus on is ln, okay, the natural log function. And the situation is, so that's what we're going to do is we're going to differentiate, and E, you notice, is in terms of ln. It's the situation. In the future, if you need to find it, here's a rule, okay? If you've got the log of some base of x, log of x at some base, and if there's nothing there, that means it's 10, base 10, then this is the rule you use, and I'm not going to ask you to do that, okay? We're not going to deal with that. So if you need that downstream, Calc 2 and Calc 3, you might a little bit. But right now, I want to get to this puppy down here. And that is this. If you've got the natural log function, if y equals the natural log function, then the derivative of the natural log is 1 over x, period, okay? The derivative of the natural log of x is 1 over x. That's the rule I want you to have. If you'll notice on that formula sheet that I give you with the practice problems, it's on there. I've got that on there too. But let's go to the next page. Let's look at a couple of examples. Again, don't worry about the second two, but look at this first one. We've got natural log of x. That's there, but we've got something else going on. We've got something bigger going on. And it turns out to be, the natural log of x is inside this other function. So it's composite. So the derivative of the outside function of this, the outside, notice, is x cubed. This thing is being cubed. The derivative of the outside is you bring the 3 down front, subtract 1 from the exponent, and then you take the derivative of what's inside. And the derivative of what's inside is 1 over x, okay? The derivative of natural log, this is 1 over x. So you end up with this out front and the x in the bottom. Therefore, the answer is this, okay? I want to look at one more, and look at this situation, these two. If you got questions, let me know. You can go back and look at those slides yourselves. I'll have those up and available. But this is something that, now this is a function, this is a composite function. It's not just natural log of x, it's natural log of 4x, okay? So you've got a function inside of here. So the derivative on the outside of this, notice, is natural log. And remember what the natural log does. It takes x to the denominator. So it takes 4x to the denominator. So this is the natural log of u, all right? The natural log of u. And the natural log of u, the derivative of that is 1 over u du. You take the derivative of this and move it up top. So in this case, you get 1 over whatever's in here, and then you take the derivative of what's in there and put it on top. Simplify it if you can, and in this case you can. So the answer turns out to be 1 over x. So you look at that, and no matter what the coefficient is, the same thing would happen. The answer is going to be 1 over x, because again, this is the slope. We can talk about that at another time. I'll tell you what, we'll do this one in a minute down on the other practice sheet. I've got this problem also on a practice sheet. So let's go there now. And I think the next stuff is a lot more complicated. Yeah, it is. Okay, so what I want to do now is go to the practice sheet again. And then go to the iPad with a couple of problems. So look at this. Look at number 5 and number 6 here are both natural log. And then I've got these down here are also natural log. I want to do these, okay? So I'll put those on my iPad here. Okay, so this is kind of an interesting pattern, you guys. Recognize it. If it's just the natural log of some function, polynomial, for instance, then the rule, if you go to the practice problem rule sheet, I've got that if y equals natural log of u, then y prime equals 1 over u du. Okay? So I just went to the sheet to look at that. But the idea is that means this is following the trend of what does the natural log function do? It takes x to the denominator. It's 1 over x. Well, that's what this does too. It takes this function to the denominator, and then you take the derivative of the function. And it ends up that derivative is going to go on top. So what we have is y prime is equal to 1 over exactly what's written there, times the derivative of what's on top there. And you can see what that is. You're getting pretty good at that now, aren't you? Do you see that that's 2x plus 3? And so the final result turns out to be, we can move that to the numerator. We get the derivative on top and the original function on the bottom. That's kind of a neat pattern of natural log of u, the natural log of some function. Okay? So that is the answer right there. Questions? Okay, let's do this product rule, and then I'm going to work through the problem set, the in-class problem set. Okay, so let's do number 14 and go from there, and then we'll move on. So notice this is a product. This is x times a natural log function. Yeah, and remember, if it's a product rule, so I'm going to write down up here so I can see it. If y equals f times g, then y prime equals the derivative of f of first one comes first, the way I've rewritten it, and we've got f times g prime. So what do? I've got y prime now. The derivative of this is going to be the product. The first term is f, the second term is g. So the first term, I got to take the derivative of x, which is 1, times g, just like it's written. Everything else just stays exactly the same. That log of x is part of it. This is f prime times g right here. Now we add to that the first term, which is x, times the derivative of the second. And the derivative of natural log is 1 over u du. So it's going to be 1 over x squared plus 5x plus 1. Du is going to go on top. And you can see what that is. That's 2x plus 5. So we end up with, if you multiply this back out, and don't get distracted by this, the 1 can disappear. We've got the natural log of x squared plus 5x plus 1. Plus, notice what we get on top. We've got 2x squared plus 5x over x squared plus 5x plus 1. Okay, and this is your answer, you guys. That's simplified. Now look, that 5x and the 5x are both there. They do not cancel. They're part of something else. They're connected. They do not cancel. you got to have this whole thing, or else factor out the x. The whole thing has got to be a factor in order to cancel. Okay?